Hi, my name is Nathan Gross, and today I'll be discussing the public lecture, The Physics of Breakfast, done by Peter Juncker. The first part of this lecture was about the coffee ring. When you spill coffee on a table, it dries in a ring-shaped pattern, which the stain is darker around the edges than it is in the middle. To attempt to explain this phenomenon, he made a model using a suspension of colloid particles in water to model the coffee spilling. He put a drop on a glass slide under a microscope, and he noticed that the particles were being pushed from the middle of the drop to the edge of the drop and aligned into a very dense packing around the edges. After conducting this experiment, he found out that surface tension was causing this. Because surface tension makes molecules want to be around other molecules, so therefore the molecules on the edges of the material want to be in the interior of the material. So they want to minimize surface area. So surface tension causes the coffee spill to fluctuate in shape, and eventually the drops will form a spherical cap. Once this happens, the edges of the drops will become pinned in place until the surface dries, thus creating a coffee ring. So basically the two things needed for a coffee ring to form are surface tension and pinned edges. The next thing he discussed is why raw eggs, which are liquid, when cooked, form a solid, scrambled eggs. This is kind of strange because usually when a liquid is boiled and cooked, it evaporates. So first what he did is he tested his underlying assumptions, which were that raw eggs are liquid and scrambled eggs are solid. And he tested this by using the universal testing machine, which basically compresses the substances and determines if they're liquid or solid. After doing this, he found out that his underlying assumptions were indeed correct, and that raw eggs are liquid and scrambled eggs are solid. So this obviously still leaves the phenomena unsolved. Why does the liquid raw eggs become the solid scrambled eggs? So first he told us that basically raw eggs are mostly water and protein. And the proteins that these raw eggs are made out of can be modeled as chains. And some part of these proteins like water and other parts don't like water. So these proteins chain up so that the parts that don't like water don't have to touch water, and the parts that do like water will touch the water. However, while we're cooking these eggs, we're heating up the proteins. And when we heat up the proteins, it causes the proteins to unchain. These unchained proteins begin to move around and stick to other unchained proteins, thus forming a new shape, a solid, of the scrambled eggs. The last part of this lecture was about cereal, and why the last few pieces of cereal in a bowl tend to clump together. Basically what happens is that the adhesion of a liquid to a solid creates a meniscus, and cereal is less dense than milk, so it is sitting on a meniscus slope that is upward, holding up the cereal. These pieces of cereal try to get to the highest point by climbing each other's meniscus and end up clumping together. The lecturer then explained that while these uses of physics may seem useless, there are actually practical applications to them. For instance, the coffee ring test can be used to test for malaria and Alzheimer's. Basically what this lecturer wanted us to understand is that physics is important because it is all around us. It governs our world, and it's there whether you notice it or not. Basically this lecture made me realize that there's a lot of amazing physics phenomena that occur in our lives on an everyday basis, and we just ignore it, we just pass by because we've seen it so many times, but it really is amazing. I also learned that just because you're researching a certain area and it seems useless, doesn't mean it is, because maybe it could eventually be applied to a different area of physics and become useful.